So we're going to be looking at what the A-level physics program consists of. First, we'll just have a quick chat about what actually physics is all about in itself. There's a lot of misunderstanding about physics, but let's just see what it really is. It's a study of reality and how reality works. We're a little bit like detectives arriving at the crime scene well after the event, and we need to find out what it is that's happened, how it's happened, what the rules are of what it is that we're observing, and so on. This set of discoveries started about 2,500 years ago with Thales. That's the gentleman on the far left of this slide. Through several hundred years of Greek science, a lot about reality was discovered. A lot of it wrong and a lot of it right as well. Then we had a long period of dark ages when people were very superstitious and worried about all kinds of strange things happening from the supernatural. Towards the end of the 18th century, we started getting more rational again, and science could start developing. People like Isaac Newton and Kepler and Copernicus and others looked at fairly obvious science, things like gravity, things that we could observe. Further on, we found, as we turned into the 20th century, that science was actually very much more interesting than the people who'd gone before actually had recognized. So people like Albert Einstein came to the forefront with his general theory and special theory of relativity, which led into things like the understanding of things like black holes, like as Stephen Hawking on the far right hand side has spent all of his life until his demise quite recently. We're going to explore a number of areas in between this, but we will not be able to, because of the complexity of them, go into some of the really, really high-end things, such as general relativity. A little bit in year one in particles and radiation, but we will go through it in much more detail in year two. You'll be examined in 3 levels. You get 2 1.5-hour exams in year 1, and then 3 2-hour exams in year 2. The first paper in year 1 is essentially just basic knowledge. Paper 2 starts going into your understanding of practicals and also has multiple choice questions and some slightly more complex questions on your basic syllabus. In the A2 syllabus, paper 1 covers everything that you learn in year 1, plus a little bit of the start of year 2, so things like simple harmonic motion is in there. And then the second paper is primarily focused on the year 2 syllabus, and both paper 1 and paper 2 have multiple choice questions as well. And then paper 3 again focuses in far more detail on the practical skills that you'll be learning, and the turning point section, which is relativity, and the last part of the year 2 syllabus that I went through on the previous slide. So this year we went on a visit to Manchester University for an open day. They learned 4 different areas that are at the forefront of physics. The first one being the discovery of the Higgs boson and why it was important and how it fitted into the Standard Model. So take you well beyond your comfort zone from year 1. They seem to enjoy that very much. Second one is hunt for exoplanets. These are planets that orbit stars that is not the Sun. The third one was looking at sticky fluids and how various things can behave in very odd ways and how they're trying to utilize that in real-world engineering. And then finally, they had some physics puzzles. The second was a visit to a nuclear power station. This was for year 2s only, and this is primarily to make sure and to firm up their understanding of the nuclear physics topic, which we cover in quite a lot of detail, how nuclear power stations actually work and what the different parts of a nuclear power station is and what their purpose is. So actually going to a nuclear power station and walking around and having a tour and seeing what these things look like in real life really helped them put their ideas together. Another trip was to the combined site of Daresbury called the Cockcroft Labs, which belongs to a number of universities in the northwest, including Liverpool, Lancaster and Manchester University, where they put on a particles masterclass where students can spend a whole day walking around looking at particle accelerators, how they work, what they were doing, what they were used for, why they were useful, and then also play a little bit with the technology themselves. And there were some very interesting demonstrations of things like the Meissner effect, which uses an area of physics called superconductivity to make something hover in midair. So hopefully you'll be a part of this and you'll enjoy it, and there's lots and lots of variety of sort of things that we'll be learning in physics, and I look forward to teaching you in the next year.